David here with another flipped classroom video lesson. Today's topic, factoring review. So we're going to go through several different types of factoring. This is the reverse of expansion, which is what we've just been working on. So let's get started. The first technique is just pulling out common factors from your expression. This is kind of like undoing the distributive property. So let's do an example. 6x squared plus 4x. So there is a common factor in both of these terms that we can factor out of each of them. So I'm going to take this a little more slowly. We're going to break these down into their factors so we can see what is common. So 6x squared is really 2 times 3 times x times x. Right? The x times x gives me the x squared, the 2 times 3 gives me the 6. So all I did is I just factored this down. You know you're done when you only have prime numbers here and you have no exponents. Okay? So let's do the same thing for the 4x. This one's a little bit more simple. All I can do here is 2 times 2 times x. Okay? So now I have my prime factors spelled out, and I can look in each of these terms and find out what's common. And so it should start to be clear now. I have 2x in here, and I have 2x in there. So that's my largest common factor, or the GCF. So I'm just going to write that step here. GCF equals 2x. Okay? Greatest common factor. Now I can pull that GCF out of each term. So the way I do that, remember I'm reversing distributive property, so that looks like this. So I pulled my 2x out, and now I have to decide what's left. Now one way to explain that is to say, what do I multiply 2x by to get back to 6x squared? And that would be 3x, because 2x times 3x is 6x squared. Okay? Now this one is a little bit more simple. I've pulled my 2x out of 4x. What's left, or what do I have to multiply 2x by to get back to 4x? And that would just be 2. So, sweet. We factored out common factor of each of these two terms, and we wind up with this. So now you can see how this is like doing distributive property in reverse. Now we have a problem that we could now apply distributive property to, and it would take us back to here. Okay? So you can always check your results when you factor, is that if you now expand this, you should wind up back where you started from. Okay? Let me give you one to try. Let's try 12x to the third plus 9x squared. Okay? So pause the video, give it a shot. Okay, let's see how you did. All right, so let's do the prime factoring. This would be 2 times 2 times 3. That gets me my 12 times x times x times x. So that's this term. 9x squared is going to be 3 times 3 times x times x. Okay, so now I've prime factored. Now let's see what's the biggest common factor in each of these. I don't have any 2's here, and I only have 1 3 there. So my GCF is going to be 3. And then how many x's do I have? I've got 2 there and 3 there. So 2 is common. So that's going to be 3x squared. So that's my GCF for these two terms. So now I'm going to reverse that, just like we did the last one. So now I have my 3x squared on the outside. What's left on the inside? What do I need to multiply 3x squared by to get back to 12x to the third? And that's just going to be 4x. Now let's take a look at the 9x squared. What do I multiply 3x squared by to get 9x squared? And that's just 3. Okay, on to the next one. Okay, the second technique that you're going to get today is the difference of two squares. And this should sound familiar because we expanded this pattern. Now we're factoring it, which is just reverse expanding. So let's take a look at a problem. 4 minus 9y squared. So we want to factor this. Now if you look at that, it's going to be kind of hard to find a GCF in there. There isn't one. So we can't use the first technique on that. So now, these are a little bit tricky because you have to kind of see what pattern you might notice. And both of these can be written as squares. So I'm going to redo that. This is 2 squared, okay? 4 is 2 squared, minus, this is 3y squared. 3y squared, with the squared out here. Remember, when the exponent is outside of a parentheses, that exponent applies to both of these. So 3 squared is 9, y squared is y squared. So now we're set up. I see I have a difference of squares. I have 2 squared and 3y squared. So now I can use my pattern. Let's review that real quick. From before, we had a squared minus b squared. This is going to be a plus b times a minus b. This is what we reviewed when we reviewed expansion techniques a couple lessons ago. So now I can use this here to factor that. So I am looking at this piece here, and I'm going to go to that one. So my a is 2, and my b is 3y. So what I'm going to get is 2 plus 3y times 2 minus 3y. Okay? Now these get a little tricky. You have to notice that this is 2 squares, could be rewritten that way, and then you see you have a difference, the subtraction, and then you have to remember your pattern here, and then go from this step to that step, which is the same as this step to that step. Okay? Let me give you one to try. Let's do that right here. Try 9a minus 16a to the third. Okay, now this one's a little bit tricky. Got it. Okay, so give it a shot. Pause the video. Come back. Okay, let's see how you did. So if you looked at this, it's hard to see whether it's a difference of squares because I have an a there. That's not a squared. But I've got 3 here. So I can take out an a as a GCF. So this becomes a times 9 minus 16a squared. Okay? Now this is a difference of squares. So I can rewrite that, that's an a, or no, that's a 9, sorry, as a times 3 squared minus 4a squared. Okay? So here's my difference of squares, 3 squared and 4a squared. So now I can apply my pattern up here, and this is going to become a times 3 minus 4a times 3 plus 4a. Bam. Okay, the third pattern we're going to cover today. It's called perfect squares. So that's 3. And let's review the pattern first, okay? My pattern with perfect squares was a plus b squared equals a squared plus 2ab plus b squared. Okay? So when we did expansion, we started with this and we used the pattern to go here. So with factoring, you're going to start with this and use the pattern to go here. Okay? So that's why these two concepts are taught right together, because factoring is undoing expansion and expansion is undoing factoring. Okay? All right. So let's take a look at an example. 4x squared plus 4x plus 1. Okay, so this is a little tricky. You have to recognize that this expression can be written this way. So I'm going to break it down nice and step by step, as you master the pattern, you're going to be able to skip some of these steps because you'll just see what's happening. So the first term has to be written as something squared. And guess what? We can do that. This is 2x squared. So this gets us back to 4x squared. And then this one has to be written as 2 times a times b. So that's 2 times, now here's my a, 2x. Now my b is going to be the square root of this number, which is just 1. And then this has to be expressed as a square, which guess what? It's just 1 squared. Okay? So this is a tricky step. Okay? Maybe pause the video if you're still struggling to see that and just look at that and see that you can go from here to here using this pattern there. We're looking for that. Okay? All right, so I'm almost done. Now I just can go, I need to get to this place, right? And so my a is 2x and my b is 1. So I know this is just going to be 2x plus 1 squared. Okay? Pretty straightforward, but also a little tricky. Great, let me erase. Okay, let me give you one to try. Okay, 9x squared plus 12x plus 4. Pause the video and see if you can use these steps and that pattern to factor that expression. Okay, let's see how you did. So, 9x squared, what is that written as a square? That's going to be 3x squared. Now this has to be written as 2 times a times b, which is going to be 2 times my a, which is 3x, times my b, which is going to be the square root of this 4. So that's going to be, there's a plus and a plus, plus 2 squared. Okay? Hang on, let's add something there. I've got to add my 2 there, and then my 2 squared. So this is my a, this is my 2, that's my a, that's my b, and that's my b squared and my a squared, like that. Okay? All right, so now that I know what my a and my b are, I can finish. This is going to be 3x plus 2 squared. Now, if some of these feel a little bit strugglicious, just stick with it, get some help. These are tricky, and just to know, this is assumed prior knowledge for this class. We are spending time reviewing it because it's really important, and I want to make sure that you have as good an understanding of it as you can get before we move on. So if you're struggling, come to extra help, ask questions during class, things like that. Let's do one more example. This one has a little twist to it. Okay, let's try this one. 8x squared minus 24x plus 18. This is a try. Before you pause the video, let me give you a hint. You're going to notice that you can't write 8 as a square, nor can you write 18. So your first step, as with most all of these problems, should be to see if there's a GCF you can take out first. So pause the video, give it a shot. Okay, let's do that. And of course there is a GCF. These are all even, so there's at least a 2. And I think that's pretty much it. So I can take out a 2. 2 times 4x squared minus 12x plus 9. So I took out my GCF, and now that can be written as a square, and so can that. So this becomes 2 times 2x squared minus Now we need to write this as a 2ab. My b is going to be 3, it's the square root of that, and my a is 2x, so that's 2 times my a times my b plus 3 squared. So now I know what my a and my b are. Here's my a, it's 2x, and my b is 3. So now I can factor this using this pattern here. My 2 comes along, it's outside of all this. It's going to be 2x plus 3. Well, that was interesting. For some reason, my camera stopped recording right when I finished this problem. So I put it back up on the board, and I just want to summarize. That 3 that we were talking about ends up right there, but because we're minus, this has to be a minus in the middle. So if you want to check your work with one of these problems, you could square this binomial, do a FOIL, and then multiply the result by 2, and if you did everything correctly, you should wind up right back where you started from. Thanks for watching.